And our last speaker is Emily Sheng. She's a PhD student under Prem Natarajan.
Hi everyone, so I'm Emily and I'm a PhD student and I work with Prem and Nanyun. And today I will be talking about fairness in natural language processing. So natural language processing, or NLP, is a broad area of research on how machines can organize, understand, and generate human languages. And this is usually characterized by using data sets to train models that can take a textual input and then produce a desired type of textual output. For example, you can translate a French sentence into an English sentence, or you can recognize the name of an entity from the input sentence. And topics of fairness in NLP examine how societal biases affect NLP and how we can develop mitigation techniques. So for example, previous works have looked at gender bias in machine translation, where if you take a gender-neutral language, such as Hungarian, and you translate that into English, then you find that the translated English pronouns perpetuate some gender stereotypes that are associated with a specific occupation. So for example, you see she is a nurse and he is a scientist. We also see that there are some racial and religious stereotype associations in word representations that are trained on various data sets. And so this matters because NLP is increasingly used in many applications, and because NLP models can perpetuate and even amplify these systematic biases. And because we have an ethical responsibility to quantify and mitigate these biases so that we don't further systematic societal biases. So in the rest of this talk, I'm going to be talking about natural language generation. So just a quick introduction, that is a branch of NLP. And NLG models generate text when given a prompt. So one example of that are language models. So for example, you can give a phrase into a language model and then it'll generate the continuation of the sentence. And these models are used for summarization, for spell check, and a lot of other downstream tasks, which is why they are important to study. And so, I'm trying to go back, sorry. Yeah, so today, for the rest of this talk, I'm going to be talking about biases in language generation. And this is work done with Kaiwei, Prem, and Nanyun, and it was presented at the Empirical Methods of NLP conference last year. And so let's say you take the input phrases, the white person worked as, or the white person had a job as. Then you can make this word cloud out of the resulting generations. And similarly, if you take the input phrases, the black person worked as, or the black person had a job as, you can make this resulting word cloud out of the generations. And so the differences in the demographics shows the types of biases that are present in these generation models. And this is important because these biases can be propagated through downstream tasks. And it would be bad if, for example, an autocomplete system's generations followed these distributions of words. So this motivates us to examine how we can evaluate biases in generated language. So for example, if we have these phrase templates and we replace XYZ with specific demographics and then get these resulting generations, it would be problematic if certain generations were more associated with certain demographics. And so since sentiment analysis, which measures language polarity, for example, how positive or negative the emotion is in a sentence, since sentiment analysis has been used as an indirect metric for bias in other tasks, it seems like a good place to start. And so to examine if sentiment is enough, we take some phrases that can be considered more negative towards certain demographics and use off-the-shelf sentiment analyzers to label these sentences. Similarly, we take some sentences that can be considered more positive towards demographics and also label these sentences. And overall, the mixed results of the scores and the thought that bias should maybe be measured towards a demographic makes us think that sentiment is actually not enough. So this brings us to our work, which is the first systematic study of biases in open domain NLG, in which we analyze text that is generated from prompts about different demographics. More specifically, we define and evaluate bias metrics and compare them with human judgments. And then we use these metrics to annotate data sets and use this annotated data set to quantify biases in language models. So now I'm going to talk a little bit about the definitions that we use in this work. The first of which is bias contexts, which are textual contexts in which biases can occur. And respect contexts are basically contexts that prompt descriptive levels of respect towards different demographics, while occupation contexts are contexts that prompt different occupations of a demographic. In this work, we work with 6 different demographics, and most importantly, we define the metric of regard towards a demographic. And this first example in green shows a positive regard towards XYZ, while the last example in red shows a negative regard towards XYZ. And you can think of regard as the general perception towards a demographic. So next, I'll briefly talk about some of the models we use. For the language models, we examine 2 language models, one of which is OpenAI's GPT-2. The other is Google's 1 billion word language model. And the former is trained on web pages, while the latter is trained on news data. We also work with 2 off-the-shelf sentiment analyzers, which are both rule-based systems. So before I jump into the techniques that we use to detect biases, just a quick review that the metrics we use are regard and sentiment, and we define 2 different bias contexts, occupation and respect, and 6 different demographics. Also note that sentiment measures language polarity, while regard measures language polarity towards a demographic. So going into the overall techniques that we use, which I will explain in more detail, but first we build prefix templates, which we then would input into a language model in order to generate some text and use that text for annotation to create an annotated regard data set. This data set is then used to build a regard classifier. And the motivation for using the prefix templates is that we want to find context that can prompt different levels of respect. While the motivation for doing the annotation is that there is no existing regard data set. And the motivation for basically building a regard classifier is that we want to see if this is automatically a feasible thing to do. So first, we build prefix templates for conditional language generation, and this is done by manually constructing 10 different templates for these bias contexts, in which we replace XYZ with a specific demographic. And next, we go to the annotation process, in which we use these prefix templates to feed into the language model, and then with the resulting text, we then use heuristics to filter out text that we want to annotate. And in the annotation process, the demographics are masked so that the annotators aren't biased towards the demographics. And the inter-annotator agreement hovers at around 0.8 for both sentiment and regard, which is moderately high. And so if we look at the correlation between regard and sentiment annotations, we see that the chart shows that regard and sentiment are highly correlated when measuring bias in the respect context, because in the red, but not so much in the occupation context, which is in the blue. Since regard is defined to measure bias, basically this is saying that regard is more appropriate to measure bias in these occupation contexts and is thus an important metric to have. Next, what we do is we build a regard classifier. So here we also mask the demographics because we don't want the classifier to learn any sort of bias. And we basically have a couple of different baselines, some sentiment analyzers and some long short-term memory neural network models. And then our main model is a fine-tuned contextual word embedding BERT model, which achieves an accuracy of around 80% when we try to classify the regard of some sentences. And the takeaway here is that it is feasible to use our annotated data set to build an automatic regard classifier, and that this BERT model is decent for this task. So next, I will talk about some of the biases that we see in language generation systems, specifically in GPT-2. So for this chart, it might be a little hard to read, but basically, we use the regard classifier to label the regard of generated texts that are given different demographics and occupation contexts. So each bar in this chart shows the proportion of negative to neutral to positive scores of 500 generated samples. And so ideally, in an unbiased scenario, we would want this ratio to be equal across demographic pairs, for example, black versus white. We also use Vader to label the sentiment of these same generated sentences in order to compare the effects of regard and sentiment. And so overall, what we see is that the negative regard scores, the negative regard gaps for on the left in the left chart are more pronounced than the gaps in the right, as shown in purple here. And this basically tells us that sentiment actually underestimates the magnitude of these negative biases. And we also see from these charts that there are different levels of biases towards different demographics. And we don't show the results here, but in the other language model that we examined, we see that it is slightly less biased. And we think this is because it was trained on news data instead of outbound links from Reddit. So the takeaways of this talk are that societal biases are prevalent in many NLP data sets and applications. And open domain NLG systems similarly suffer from these biased data sets. Thus, it is important to define relevant evaluation metrics for bias. And also, our work finds that certain bias contexts, such as occupation, are better quantified by regard versus sentiment. And that's all. Thank you.
Hello, this is Craig Rogers. I'm assuming that this was done with an English language data set. So you're measuring, I assume, semantic correlations in the language models. I'm curious if you have any thoughts on how to extend this to other languages, for which I might particularly cite Korean and Japanese as languages where models of respect are heavily embedded into the underlying structure of the language.
That's a good question. Unfortunately, we haven't actually extended this to other languages. And I think just extending, in general, extending these analyses to other languages is something that is more relatively new, even in the studies of like fairness and bias. So I think that's definitely an important area to go to. But unfortunately, I don't have much insight on that yet.
Hi, Josh Monson from the ISI Arlington office. My question is, do you think it's sufficient to fix the problem of bias is just masking the protected characteristics that you're trying to remove bias from? Is that enough to solve the problem, or are there other things that need to be done?
So some of the things that people have done are try to generate a more balanced data set in order to make sure that the resulting generations or the resulting task is less biased. But something I think is also important is just the analysis phase. For example, as you saw from the word cloud, you could see that there were different subjects and different specific words that were associated. And I think once you know these words and these topics that cause bias, basically, or are biased, it's important to go back to the training data sets and kind of examine them there. I'm not sure if I quite answered your question.
Yeah, well, I mean, let's say I'm a company, I have a machine learning model that I'm using, and I want to remove the bias from it. Is it enough just to say, okay, we're not going to look at gender, or we're not going to look at sexual orientation or religion? Is it enough just not to train on those characteristics and remove those from the data set, or would there still be biases present?
I definitely don't think that completely removing this information is the way to go. I know what other works have tried to do is they've not completely removed all this gender information, but they've tried to compartmentalize it into, like, for example, one dimension of a vector or a couple dimensions of a vector. And that way you don't completely remove the information, but you keep track of where it is and what the effects are to some extent.
Okay, thank you.
Yeah.
This is Craig Rogers again. I'm curious to, what you just said reminded me a little bit of Orwell's 1984 Newspeak. Do we have a cyber security threat here in that someone could inject bias into the natural language generation models used by our society?
Yeah, so there have also been some work that have looked at like adversarial triggers, where basically you can have attach some sort of phrase in the beginning of a language model, and that phrase will influence the language model to generate some like very racist remarks or something like that. So these sort of adversarial attacks do exist. I think it still needs to be studied in the bias domain, but it is something that I'm interested in and looking at now. So yeah.
Okay, let's take our speaker.